All right, so we're going to look at the domain and range of a graph. And as you can see, I've got my graph paper here. If you're taking notes, you probably want to have some graph paper handy as well. So remember what domain is. Domain is the set of inputs for a relation, and range is the set of outputs. Now, the nice thing about doing this with a graph is it's a very visual process. Not really any work to show, but it can be difficult when you start getting into graphs that have breaks or gaps, or they have open circle for boundary points, or they have asymptotes. So we're going to try to address all of those in this video. So let's look at the first example. I'm going to provide a graph, and what I want you to do is find the domain. Okay, find the domain of this graph. Sorry, how about find domain and range? And range. And we're going to write the domain and the range in interval notation. So if you're not familiar with interval notation, you may want to go review that. But our first example is going to look like this. Let's put our y-axis there, and let's put our x-axis here. And then we'll just we'll assume that that's 1 unit. So there's 1, 2, 3, 4. There's 5, and we'll just kind of mark this consistently throughout. There's -1, 2, 3, 4. There's -5, and we'll use the same scale on the y-axis. So 1, 2, 3. There's 4, and then -1, 2, 3. So there's -3. So each tick mark here is 1 unit. So that's our setup, and let's graph a function here. So let's say at the point -3, 2, let's say we have an open circle, and then we have a slanted line with a slope of 1 going down and to the left. So something like this, and it terminates with an arrow, meaning it keeps going forever. So that's the first part of our function. And then let's say that our function picks up again. Let's say it picks up again up here at -2, 3 with a closed circle like this. And then just to keep things simple, we'll have a slope of -1 going down and to the right from there. And this guy terminates with an arrow as well, meaning it continues on. Okay? And so let's talk about how to determine the domain and the range of this function that has 2 different pieces. And so domain is the set of inputs, the set of x values. So if we think about all of the x values represented on this graph, we think about what if we were to collapse our graph, from onto this x-axis. Well, let's take this first piece. If I collapse this piece onto the x-axis, I'll have an open circle here at -3, and then I'll have shading to the left and forever, because this graph goes to the left forever. So that's what happens if I collapse this piece down, if I crush it down to the x-axis. If I do the same thing with the next piece, I'll have a closed circle at -2 on the x-axis and continuing to the right forever. And so that red region is the domain of this function. So I just have to write that in interval notation. So the domain will be the union of those 2 intervals. So this first region, this first interval is -∞ to -3, not including the -3, union -2, including it, to infinity. And that's our domain. Okay, so domain is usually simpler than range. Because we're dealing with functions, as you move left to right, this thing can't overlap itself because it has to be a function. Okay, so let's look at the range now, which is typically a bit trickier. Hopefully the green marker will show up here. So now, same idea. Range is the set of outputs, though, the set of y values. So rather than collapsing the graph down onto the x-axis, we collapse the graph onto the y-axis. And now the 2 pieces of this function can overlap. So let's start from the bottom to the top. So for domain, you go left to right, because negative numbers are to the left, positive numbers are to the right. So you go negative to positive. For range, you still go negative to positive, which means you start at the bottom and go up. So that's kind of tricky. That's another tricky part about range. If you think about how you read text, you read top to bottom and left to right. So the left to right is very natural for domain, but the bottom to top is not natural at first. You have to go from negative to positive. Well, we can see that if I were to collapse this graph onto the y-axis, the graph goes down forever because both of these point down forever. So I know that I'll have a down arrow forever. Okay, and then I'm going to shade, if I just look at this region, I'm going to shade everything up to 2 here, right? Because this piece here collapses and shades everything from negative infinity up to negative 2. Then the question is, do I put an open circle on 2 or do I keep shading, or what do I do? Well, while this piece stops at 2 and does not include it, this other piece does include 2. So 2 should definitely be shaded. In fact, the range doesn't even stop there because this piece of our graph continues above 2 all the way up to 3. And then we do the same analysis at 3. Is 3 in our range? Well, this point collapses and closes that point in. So this point has to be in our range. If there's a y value on your graph at a point, you have to shade it, even if another part has an open circle that's not including it. Okay, so that's kind of tricky. So I know 3 is shaded. But then if I look past 3, no piece of my graph goes above 3 in the y direction. So my range stops right there at 3 with this closed circle. So now my range is this simple interval, one interval in this case. So my range goes from negative infinity up to 3, including 3. So that's the domain and range of this kind of strange function. It's called a piecewise defined function because it's broken into pieces. But the range can be tricky when you have that and trying to find where they overlap, okay? So hopefully that makes sense. Now, let's do some examples with asymptotes. So not necessarily open or closed circles, but our graph still has boundaries. And you've probably been exposed to asymptotes at some point. Okay. Now we're going to go through the same process, set up our x-axis and our y-axis. There's our y-axis. My paper here is still kind of wet. Sorry, let me try to clean that up a little bit. Okay, so now here's our y-axis. Here's our x-axis. And let's say we'll mark our units again here. So each of these is 1. So this is -3, this is +3. We'll do the same thing in the x direction. So this is +5. Here's -5. And then let's say that our function this time has an asymptote, a horizontal asymptote at y equals -1. Okay, so we've got this asymptote, this boundary for our graph. And let's keep our graph simple. Let's say it goes through the origin, so you'll want to make sure to mark that. But as we go to the left, you don't have to be terribly precise here if you're taking notes. You drop and you get infinitely close to this asymptote. Okay, so we have to indicate an asymptote if there's this boundary that we're getting infinitely close to. And as we go to the right, you're just going to keep following that behavior. You're going to go up like this with an arrow terminating on the end. Okay, so that's our function. We need the domain and the range. If I think about collapsing this graph onto the x-axis, right, I know because of this arrow, it's going to go to the left forever and it's going to be shaded all the way over to this arrow. And so the domain is -infinity to infinity. There's no breaks in this as you move left to right. So the domain is negative infinity to positive infinity. Now the range, if we collapse onto the y-axis, again go from the bottom to the top, below -1, our function never drops below -1. So none of these y values are in our range. So the first y value that we sort of encounter is just right here above -1. But our graph is getting infinitely close to -1. So the way we indicate that is -1 is the boundary for our range. We just never touch it. So we have to put an open circle on it, okay? So even though the graph itself doesn't have an open circle, our range will, because we're getting infinitely close to this value, we just don't reach it. And then we can start shading immediately above, like this, until we get up here. We have an arrow, so it continues going up forever. So our range, from bottom to top, our range is -1 to infinity, but not including the -1, okay? So that's kind of tricky with an asymptote. In fact, I don't think we need to do an example with a vertical asymptote now. It's the same thing. It changes your domain instead of your range. It affects your x values instead of your y values. So there are some interesting cases where parts of your domain or range could be all real numbers, no breaks, no gaps, nothing like that, goes forever in both directions. You could have an asymptote. You have a boundary in your graph based on an asymptote. Or, in our first example, you could have a boundary of an open circle or a closed circle. So hopefully that's enough to get you through the domain and range of a graph.